MIDI keyboard control of Wi-Fi enabled relays. Project proposal by Enrico, Elizan, Jonathan Greene, Embedded Systems, Spring 2016. Our goal for this project is to wirelessly control a set of relays using an electronic keyboard.
To complete this project, we'll have to develop two separate embedded devices that will communicate with each other. We'll design one embedded system that will be integrated into an electronic keyboard. I'll provide a USB to Wi-Fi bridge to broadcast the relay control information. Our second embedded device will be a relay board with integrated Wi-Fi. This device will receive the broadcast messages from the keyboard and activate the relays. We plan on using the following parts during this project: a Casio electronic keyboard, Raspberry Pi B+, a pixel display with built-in capacitive touchscreen, USB wireless adapter, surplus parallel port based on relay board, and a Wi-Fi enabled microcontroller board.
Phase 1. Electronic keyboard. The Casio EZ250i keyboard will be used to generate the MIDI control signals. MIDI stands for Musical Instrument Digital Interface and is a communications protocol used to encapsulate information about musical notes as they are played. This information can include items such as the note played and its intensity. We will use MIDI information to identify key presses on the keyboard. The keyboard provides a USB interface output that we will use to transfer the MIDI information to the Raspberry Pi for processing.
The Raspberry Pi is an inexpensive board that runs Linux and contains a few programmable GPIO pins. It is a good choice for our keyboard interface because of its small size and available ports.
For this project, we will be adding some additional hardware to the Raspberry Pi. The Pi will be outfitted with a USB Wi-Fi adapter to allow it to connect to the local wireless network. To provide access to the user interface, we will be installing a 2.8-inch display on the Pi. The display contains a built-in capacitive touchscreen that will be used for menu selection and navigation.
We have several available software options surrounding the Pi. For our initial design, we will use a Debian Linux for the operating system. For the backend conversion of the MIDI protocol and establishment of the USB to Ethernet bridge, we plan on using Java Embedded. This choice was based on establishment support for MIDI devices. Another option we could explore is using Node.js for the backend. We will have to determine the best option during the development. For the front-end interface, we'll be using JavaScript with HTML5 and AngularJS.
Phase 2. Relay board. To provide the AC switching needed to control the lights, we will upcycle an old surplus relay board. The board is outfitted with 6 external 3-prong power outlets. The relay board does not contain a microcontroller. It was designed to be controlled by an external PC via a 25-pin parallel port interface. Our goal for this project is to convert this relay board into a Wi-Fi enabled embedded system that is controlled via MIDI signals sent from the keyboard. The interior of the surplus control board has a bank of 6 AC relays, which run on 24 volts. A relay is a current activated mechanical switch. The relays in this board are used to control the AC output of the 6 outlet plugs. The interior logic, or internal logic of the board, has the relays triggered via transistor from the outputs of this buffer chip. The input pins of the buffer are brought out to a 24-pin connector. Each relay has its own individual pin on this connector. When voltage is applied to an input pin, it will activate one of the relays. The microcontroller we are embedding into the relay board is the ESP8266. This board has a built-in Wi-Fi chip, 9 GPIO pins, and is available for under $10. The board operates at 3.3 volts logic and requires 250 milliamps current. The relay board provides 5 volts, so we will have to add a 3.3 volt regulator. We obtained 2 versions of this board. One version of the board is bare bones, and the other includes a built-in USB serial UART and 5 volt to 3 volt converter to aid in our initial design.
The ESP8266 is programmable in the same manner as an Arduino via the Arduino IDE. The board supports Wi-Fi access point mode, so we may explore this during development. The ESP8266 will be installed inside the relay board enclosure, allowing it to operate as a standalone embedded system. We plan on developing an Android app separately to control the relay board as a standalone device.
This concludes our project proposal. Thank you.